Okay, the first thing we're going to be doing is reviewing all the things about algebra that you should know when you start this course. Okay, real numbers and algebra, symbols and sets of numbers. Okay, a whole number is a number that starts with 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A natural number, or sometimes it's called a counting number, and you'll see it both ways, is 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay, just like you count. Integers are your positive and negative numbers. No fractions, no decimals. So this is listed as -5 through 5, but it continues. Okay, so there's some of the basic things about numbers. We'll be talking about other numbers in a second, other types. An equality sign is an equal sign, and if you graph it, it's a closed dot. An inequality sign is a greater than sign. If it's graphed, it's an open dot shaded to the right. A less than sign is an open dot shaded to the left. A less than or equal has this little line under it, which means that it's also part of it. So it's a closed dot shaded to the left. And a greater than or equal to is a closed dot shaded to the right. And not equal is an open dot. This is a set of brackets called curly brackets, and it's used to enclose elements of a set. So right now we're just going over all these basic things that you need to know. Okay, so we talked about whole numbers and natural numbers. Okay, they're terminating decimals. Terminating decimals is a decimal that ends, like 2.5, 2.62. Okay, these are all, so far, rational numbers. Rational numbers are anything that can be written into a fraction form where the denominator is not 0. Other things that are rational numbers are repeating decimals. Repeating decimals are decimals like 0.33333333, which can be written as 1/3, so it is a rational number. Fractions, integers, which we already talked about, and perfect square roots, like the square root of 25 is 5. So that is a rational number. So we have rational numbers and irrational numbers. An irrational number is any number that's not rational. It cannot be written as a fraction. And things that are irrational are non-perfect square roots, like the square root of 2. That's a decimal that just keeps going, going, going. And a non-repeating decimal, a decimal that keeps going, 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 going. No repeat on it, like pi. Now here's just a little thing to understand. We have the number system. Under our number system, we have real and imaginary. We're going to get to imaginary in a later class, but we have real. This is where we set most things up. Under the real, we have rational numbers and irrational numbers. It's always easier to memorize the irrational numbers because they're non-perfect square root, and then non-repeating decimals. Everything else is rational. So you need to be able to tell the difference between a rational and an irrational number. 2/3 can be written as a fraction, so it's rational. 0.4 is a terminating decimal, so it's rational. It also can be written as 2/5. 0.666 is a rational number because it's a repeating decimal. It can be written as 2/3. 3 is a rational number because it's a whole number, it's a natural number, it's an integer, etc. It can also be written as 3/1. Square root of 5 is an irrational number because it's a non-perfect square root and a non-repeating decimal. So if I do the square root of 5, my calculator gives me approximately 2.236066797, blah, blah, blah. So I see no repeating, and it doesn't stop. Just because it ends on the screen does not mean it stops. Okay, some properties you need to know. You need to know the commutative property, and it works with both addition and multiplication. And what the commutative property says is that order doesn't matter. You can add 2 and 4 or 4 and 2, and they're the same. Same with multiplication. 2 times 4 and 4 times 2 are the same. The commutative property does not work with subtraction or division. 2 minus 3 and 3 minus 2 are not the same. 2 divided by 3 and 3 divided by 2 are not the same. We also have the associative property of addition and the associative property of multiplication. The associative properties say that the grouping symbols can change position, but it doesn't change your answer. So as you can see here I have the 2 and the 4 in the parentheses. Here are the 2 and the 3 in the parentheses. 2 and 4, 2 and 3. Doesn't matter. They're going to come out the same answer. This is not true of subtraction or division. The distributive property says that if you have a number in front of a set of parentheses, you can give it to each of them through multiplication. So 2 times 7 is 14, and 7 times 3 is 21. Add them together, and you would have 35. You could also look at it this way. If I had 12 and 8, 12 is 3 times 4, and 8 is 2 times 4. So I took the 4 out, put it out front, and put the 3 and 2 inside. That's using the distributive property in reverse, and we do that a lot when we factor. Okay, the identity properties. The identity property of addition says that if I add 0 to a number, I will get the same number, and if I multiply 1 by the number, I will get the same number. There is not an identity property for division or subtraction. The inverse property says that if I take a number and I add its opposite, for example, 2 plus negative 2, I will always get 0. The inverse property of multiplication says that if I take a number and multiply by its reciprocal, for example, 4 times a fourth, because the reciprocal is flipped over, I will get 1. Absolute value signs tells the distance, not the direction. Therefore, it's always positive. When absolute value signs are taken off, unless there's a negative weighting outside, it will always be positive. When I say it tells distance, not directions, it's like if I back up 6 miles in my car. My odometer is not going to say -6, it's going to say 6. It only tells you how far I went, not what direction I went. So the absolute value of -3 is 3, because if I look at a number line, I'm 1, 2, 3 hops from 0. The absolute value of 3 is 3, because I'm 3 hops from 0. The absolute value of 0 is 0. The absolute value of -3, -3's absolute value is 3, but there's a negative weighting outside. That's what I was talking about in the front. So the actual answer will be -3. Sometimes you do operations with absolute values, and it depends if the operation is in the absolute value or outside of the absolute value, what you do first. Since the operation is inside the absolute value, I have to subtract first. So 3 minus 4 is -1. Then I take the absolute value of -1 and get 1. On the next one, the operation is outside the absolute value. So I take the absolute value of 3 and the absolute value of 4, then I subtract and get -1. Okay, we're also going to talk about comparing numbers. Now remember, this is a hodgepodge of a lot of things for this review, because these are the things I need you to remember, put back in your brain before we start on specific topics. Okay, anytime I'm comparing two negative numbers, the smaller number, 4, will always be the highest. The reason why is, think of money. I owe $4, I owe $6. I'm in better shape if I owe $4. When I do absolute values, do the absolute value first. Absolute value of 2.7 is 2.7. The absolute value of 2.5 is 2.5. Now, how do you do decimals? Well, I do it like alphabetizing, like banana and bandana. 2, 2, decimal, decimal, 7, 5. 7's bigger. What about fractions or mixed numbers? Well, one, we don't use mixed numbers in algebra, so you're always going to see improper reduced fractions. But fractions are probably or mixed numbers are hardest to be able to compare. So your choices are, you can change them to decimals and then compare them like I did the last one, or you can change them to improper fractions by multiplying and adding. 12 plus 5 is 17 over 6, and 4 times 2 is 8 plus 1 is 9 over 4. And then you cross multiply. 17 times 4 is 68, and 6 times 9 is 54, and 68 is bigger than 54, so 2 and 5 6 is larger than 2 and 1/4. You might have just been able to look at that. They both had 2's. 5/6 is bigger than 1/4. But just reviewing. Okay, adding real numbers. That means integers or anything with positive and negatives. If signs match, meaning they're both negative or they're both positive, you just add and keep the sign. If the signs do not match, you subtract from the larger number the smaller number and keep the sign of whatever the larger number is. To find opposites, an opposite is the same thing as an additive inverse. So the opposite of 3 is -3. The opposite of -4 is 4. The opposite of 1/3 is -1/3. The opposite of A is -A. Subtracting real numbers. You are not allowed to subtract. You must change it to addition and then change the sign of the number behind it. Then use your addition rules. So here we go. We're already off of integers, and we're already in rational numbers because integers should be something that you already have under your belt. Okay, first thing you have to remember on rational numbers and fractions is you have to have a common denominator. I do. So I keep that common denominator. Then I have 3 plus -1. They don't match, so I subtract. 3 minus 1, 2. Keep the sign of the larger. 3 is larger, it's positive, so my answer is 2/10. Reduced to 1/5. Common denominator, 6 and 9. Not common. Common denominator, 6 and 9, is 18. 6 goes into 18 3 times, so I had to multiply by 3, so I had to multiply its numerator by 3. 9 goes into 18 2 times, so I have to multiply the top by 2, so 5 times 2 is 10. Add. The signs match, so I add and keep the sign, 13/18. Common denominator? No. 5 and 3's common denominator is 15. I multiplied by 3 to get to 15, so I multiply the top by 3 and I get -12. I multiplied by 5 to get to 15, so multiply the top by 5 and get 10. The signs do not match, negative and positive, so I subtract. 12 minus 10 is 2. Keep the sign of the larger. 12 is larger, it's negative, so it's -2/15. Subtraction. I'm not allowed to subtract, so I change it to addition and change the sign behind it. It was negative, it's now positive. Once I do that, I find a common denominator, 24. Multiplied by 3, so I multiply by 3 and I get -9. I multiplied by 8, so I multiply by 8 and I get 8. I'm adding now. -9 plus 8, subtract 1, keep the sign of the larger, -24. Okay, multiplying and dividing real numbers. A positive times a positive is a positive. A negative times a negative is a positive times a negative, or a negative times a positive is a negative. You can also count the number of negative signs you have. If you have an even amount, your answer will be positive. If you have an odd amount, your answer will be negative. So I'll show you both of those. Things that you need to remember. 0 times a number is always 0. It doesn't matter if it's positive or negative. You're not allowed to divide by 0. If you have a 0 in the denominator of a fraction, it's undefined. And you can divide 0 by a number, and that answer is 0. You also need to know what reciprocal is. Reciprocal is the flipped version of the number. So 1/4 flipped is 4/1, or 4. -1/4 flipped is -4/1, or -4. 3 flipped is 1/3, so they're reciprocals. We're going to need reciprocals when we get to division. Okay, so first thing, division and multiplication is easier than addition and subtraction because you do not need a common denominator. I have one negative sign, so my answer is going to be negative. Then I scribble it out and don't worry about it. Now, any numerator can reduce with any denominator. I have a 2 in the numerator, and 2 goes into 2 one time, and 2 goes into 8 4 times. 7 cannot reduce with 3 or 4. So 1 times 7 is 7, 3 times 4 is 12. -4 15ths times -9 16ths times 14 15ths. I have two negatives, which makes a positive answer. I scribble them out so I don't have to worry about them. 4 goes into 16 4 times. Now 9 does not go into 15, but 3 goes into 9 3 times, and 3 goes into 15 5 times. This 3 also can go into 3 one time, and here 5 times. 14 cannot go into 4, but 2 can go into 14 7 times, and 2 can go into 4 2 times. So 1 times 1 times 7 is 7, and 5 times 2 times 5 is 50. So 7/50ths. Now, if you're sitting there wondering why we're doing this, we're going to be doing much harder multiplication, division, addition, and subtraction using rational numbers and variables. They're going to have the same properties. Therefore, we need to know the properties and know how to multiply, divide, add, and subtract just plain fractions so we can use those properties when we get to that point. So we need to practice. -4/5 times 1/6 times -3/9. 1, 2 negatives, which is positive. I scribble them out. 4 cannot go into 6, but 2 can go into 4 and 2 can go into 6. 1 can't reduce anything. 2 can't reduce 5, 3, or 9. 3 and 3 can reduce. So 2 times 1 times 2 is 2, and 5 times 1 times 9 is 45. So 2/45. Now, division is where the reciprocal comes in because you're not allowed to divide. So what you do is you write down the first one, you change the division to multiplication, and you flip the back fraction. That flipped version of that back fraction is called its reciprocal. So what I'm going to do now is going to flip them all and get ready to multiply. Okay, now I just use the multiplication rules. 7 cannot reduce with 8 or 5, but 6 and 8 can reduce with 2. So I get 21/20. Please do not get tempted to make that 1 and 1/20. We do not use mixed numbers in algebra. So leave it as an improper reduced fraction. The next one, I have 1 negative, so it's negative. 4 goes into 8 twice. And 3 goes into 9 3 times and into 15 5 times. So I get 5/6, -5/6. 1, 2 negatives, which is a positive. 6 and 8 can reduce by 2 each. 7 goes into 21 3 times. 4 times 1 is 4, 3 times 3 is 9, 4/9. Okay, so we reviewed how to multiply, add, subtract, and divide fractions. We'll be using that as the lessons increase over the chapters. Okay, exponents, roots, and order of operations. Okay, a lot of people get mixed up with exponents, so I'm going to give you the exponent rules, and then I'm going to tell you how I handle them. Okay, if you're multiplying, and the bases match like the two x's, keep the base and add the exponent. So 5 and 3 is 8, x to the 8th. If dividing and the bases match, keep the base and subtract the exponents. 5 minus 3 is 2. Or sometimes I will do canceling, saying if I have 5 x's on the top and 3 x's on the bottom, there'll be 2 x's left on top. Still gives me the same answer. If a power is raised to a power, meaning there's 1 on the outside, you keep the base and you multiply the exponents. 4 times 6 is 24. Any base raised to the 0 power is 1. I don't care what the base is. A to the 0 power is 1, 21 to the 0 power is 1, -5 to the 0 power, 1. Rule for negative exponents, and you're not going to find this in a book. This is my rule. A negative exponent says, please move me. If I'm in the numerator, take me to the denominator, my exponent becomes positive. If I'm in the denominator, take me to the numerator, and my exponent becomes positive. Then simplify me. So I'm going to start with a to the -2. It says, the negative exponent says, I'm in the wrong position, please move me. If I'm in the numerator, take me to the denominator, and my exponent becomes positive. So I did. There's nothing left for the numerator, so I put a 1. Here's the next problem. And I'm going to set this over top of each other. Okay, 2 to the -1 says I'm in the wrong position, please move me. my exponent becomes positive, so it goes to the denominator. A does not have a negative exponent. In fact, it has, even though you can't see one, it has a positive 1, so A stays. B to the negative 2 says, I'm in the wrong position, please move me. I'll become positive. And 3 to the negative third on the bottom says, I'm in the wrong position, please move me, and I become positive. So on the top, I have 3 to the third, which is 27a, over 2b squared. So all we're doing is moving with the negative exponents. So let's try a couple. I have 3 to the negative fifth. So I have negative 3 to the negative fifth. So negative 3 to the fifth goes to the bottom over 1. That says, now please notice there are no parentheses. So that 3 and that 5 are the two that go together. The negative doesn't. So it's going to stay negative. Doesn't matter if the 5 goes with it or not. It's still going to be negative. And it's going to be 1 over negative 243. Because 3 to the fifth power is 243. Here is a negative, but it's not on the exponent. So it is not moving, only if it has a negative on the exponent. What this says is 2 is being raised to the fourth power, 2 times 2 times 2 times 2, which is 16, and there's a negative on the front. On the next one, this exponent does have a negative, so it is going to the bottom. This negative doesn't, so it's staying on the top. And I get negative 1 over 16. This is brought into both of them. And if you don't see anything, put a little 1 so you make sure you bring it in. So it's 4 to the third over 5 to the third. There are no negative exponents, so nothing's moving. So I have 64 over 125. In this case, the negative is inside the parentheses, so it's negative 4 times negative 4 times negative 4 times negative 4. So negative 4 times is a positive 256. 6 to the 0 power is 1. Negative 5 to the 0 power is 1. Now, what if I had 2a to the 0 power? Well, the 0 power only goes to a, so that would be 1. I'd still have the 2, so that would be 2. So be careful that you're only taking the exponent to what it belongs to. A has a negative exponent, so a squared is going down. 2 does not. It's staying up. This gets handed in. 2 to the negative 3, a to the negative 3. The 2 to the third goes down, a to the third goes down, 1 stays up. 1 over 8, a to the third. 2a, b to the negative 1 to the second power. 3, negative 1, a to the negative 2, b to the 4. Now, this is how I handle my exponent rules. And I suggest that if you're not good at exponents, this is where you handle yours. Step 1, bring in. So this has a 1, this has a 1. I'm multiplying them all by 2. So I get a squared, 2 squared, b to the negative 2. This doesn't have anything to bring in. So I have 3 to the negative 1, a to the negative 2, b to the 4. Step 2, move up or down. Move your exponents. Move negative exponents. 2 squared is not, so that's 4. A squared is not. B squared needs to go down. 3 to the negative 1 needs to come up. A to the negative 2 needs to come up. B to the 4 stays down. 3. Combine / simplify. Well, 3 times 4 is 12. A squared and a squared is a to the 4th. B squared and b to the 4th is b to the 6th. Nothing to cancel. Finished. So I always bring in. I always move up or down my negative exponents second. Then I always combine or simplify. And it makes my life a lot easier because I know what step I'm going to next. Bring in b to the 8th. See, now that it's brought in, I don't have anything to move, and I have nothing to simplify. Make sure you put a little 1 on each of them so when you bring it in, you know that it's getting it. 6 to the 3rd, x to the 3rd. 6 to the 3rd is 216. X to the 3rd, nothing moves. A little 1. That negative's in there, so I have 4 negatives, which is a positive. 2 to the 4th power, y to the 8th power. 2 to the 4th power is 16. So 16 y to the 8th. Bring in, move. Remember, this is a little 1. There are 2 negatives, so it's positive. I bring it in before I move them. I always do. 3 to the negative 2, x to the squared, because that's positive, and y to the negative 6. Now I move. 3 squared goes down, x squared stays up, y to the 6 goes down. X squared over 9y to the 6. Now, some people will move their stuff before they bring in. I always bring in and then move it. I just found in the years that it's easier. Bring in nothing. Negative 2, x, y to the negative 14. 1, bring in. Now remember, I have negative 3, so it's times a negative. 3 to the 3rd, x to the 12th, y to the 9th. A negative times a negative is a positive, and 27, that's 3 to the 3rd times 2 is 54. I have an x and 3 x's. Didn't write right. X and 12 x's. 3 times 4 is 12. So 1x and 12x is 13x. So x to the 13. The y to the 14th goes to the bottom. Y to the 9th stays on the top. Now simplify. If I have 9 y's on the top and 14 y's on the bottom, I can cancel them out and leave only 5 y's on the bottom. So my answer would be 54 x to the 13th over y to the 5th. (25) squared y to the 4th over negative 5 x to the 6th y to the negative 5th. And the whole thing is squared. So put a little 1 here and a little 1 here and bring that 2 in to all the numerator and the denominator, including that negative, which makes it positive. So I get 25 squared x to the 4th y to the 8th over 5 squared x to the 12th y to the negative 10th. 25 squared. Okay, now I need to move things first. And the only thing that moves is this y to the 10th. So I'm going to take the lazy way out and just put the y to the 10th up there. So now I'm going to reduce 25 squared divided by 25 is 25. So 25, that takes care of these two. If I have 4 x's on the top and 12 x's on the bottom, that leaves 8 x's on the bottom. And I have 8 y's on the top and 10 y's on the top, so I have 18 y's on the top. Bring in, move up or down, simplify, combine, combine and simplify. Okay, next basic thing we need to talk about is scientific notation. Scientific notation is a way to make a very big number or a very small number into a number that we can handle. And as it says, scientific notation is used mostly by scientists, but you need to know what it means in case you have to move it back and forth. Scientific notation is in the form of blank times 10 to the blank. The first blank is in decimal form and it only has 1 digit before the decimal. The decimal has to be greater than 0 but less than 10. So anything greater than 0, actually greater than 1 and less than 10. Okay, and the number up here is the number of hops it took to move it. Standard notation is the way it's normally written with all the zeros. Okay. Okay, so here I have something in standard notation. I want it in scientific. So I have to take the decimal that's at the back, and I need to hop it over until only one digit's in front of the decimal, and when it is, the number's between 1 and 10. So 2.48 is between 1 and 10, times 1, 2, 3, 4, 5, 6, 7, 8 hops. So that's where I got the 2.48 times 10 to the 8th. Okay, this is a small number, so I need a number that's between 1 and 10. 2.48, that's between 1 and 10. And I did 1, 2, 3, 4, 5, 6, 7, 8 hops. But I can't have it the same as the other one because the two numbers aren't the same. So as you can see, this was a very small number that was under 1. To designate that, you use a negative exponent, so it's a negative 8. To change from scientific notation to standard notation, you go backwards. So you write your decimal, and it says take 5 hops, 1, 2, 3, 4, 5, and I add 3 zeros, and here's my answer. This one says to take 2.96 and take 5 hops, but make it smaller. Why? Because that's a negative exponent, that's a positive. Positive's going to make it a bigger number, negative's going to make it a smaller number. Okay, the definition of square roots. Square root always has two answers, a primary root and a secondary root. The primary root is positive, the secondary root is negative in most cases. So the square root of 36 is 6 or negative 6. Usually we only work with the positive square root unless it's otherwise stated. So we're going to be working with the primary or the principal. Okay, so the square root of 0.81 is 0.9. The square root of 144 is 12. The square root of 49 over 81 can be split into the square root of 49 over the square root of 81, which is 7 over 9. The square root of negative 81 has no solution because it's a non-real answer. In fact, it's an imaginary answer. I'm not allowed to have a negative number under a square root. Okay, order of operations. In order of operations, you probably have heard, please excuse my dear Aunt Sally, or please pardon my dear Aunt Sally. Please being parentheses. Excuse or pardon is powers or exponents. My dear is multiplication and division. Aunt Sally is addition and subtraction. The problem is people follow that specifically and always do multiplication before division and addition before subtraction, but that's not true. Multiplication and division are done from left to right, so whichever one you hit first, you're going to do. So you might do my dear, and you might do dear my. And you might do Aunt Sally, and you might do Sally Aunt, because the same thing happens with subtraction. So be careful that we're going left to right. But it's a nice way to just remember the order of operations. Okay, so on the first one it says do parentheses. I go to the parentheses, and there's really nothing inside to do, so that's done. Powers and exponents, nope. Multiplication and division. I hit a division right there. I must do that first. Negative 34 plus negative 4 times 5. Multiplication, division. I have a multiplication. Negative 34 plus negative 20. Addition and subtraction. I have an addition. Negative 54. If you don't do it in order, you're going to get an incorrect answer. Your calculator does everything in order of operations. So you have to remember that because sometimes we don't want it to do order of operations, and I'll have to show you what to do at that point. Okay, so let's go to the next one. Parentheses. Absolute value signs would be considered parentheses. Negative 2 to the 4th plus 4 times negative 6. Powers. 2 to the 4th is 16 with the negative in front is negative 16 plus 4 times negative 6. Multiplication or division. Multiply. Negative 16 plus negative 24. Add. Negative 40. Okay, now in the next one we have parentheses and brackets. And what parentheses and brackets are brackets are just like a bigger set of parentheses. So you look inside and you start working from the middle of that. So I'm concentrating on this. and I start at the top, parentheses, 9. Powers, I'm just looking in here, nope. Multiplication or division, nope. Addition or subtraction, yep. 4 minus 9 is 5. So I have negative 5 squared minus 8 times negative 5 minus the square root of 36. Okay, so that's gone. Okay, powers and exponents. Powers, negative 5 squared is 25, minus 8 times negative 5 minus, at this point is when you would do your square root. Square root of 36 is 6. Multiplication or division. Multiplication, negative 8 times negative 5 is 40. 25 plus 40 minus 6. Addition or subtraction. Additions hit first, 65 minus 6, 59. Answer 59. Parentheses. 1/2 plus 3/8. So I need a common denominator of 8, so I have to change this to 4/8. That gives me 7/8. Powers. Negative 1/4 squared times negative 1, that means negative 1/4 times negative 1/4 is 1/16 minus 7/8 plus 48 divided by 3 is 16, and the square root of 16 is 4. Addition or subtraction. Well, I have both, but I hit subtraction first. So I must subtract first. This becomes 16, this becomes 14. Changing it to a common denominator. So I get negative 13/16 plus 4. Four is the same thing as 64/16. So 64 minus 13 gives me 51 over 16. Order of operations. Now, I told you your calculator would always do order of operations, which means that if I go to these next two problems and place them in exactly how they are now, I'm going to get them wrong. Because I don't want it to divide here in the middle. I want it to do all of the numerator and do all of the denominator and then divide. So I need to understand that when I have more than one thing in the numerator or more than one thing in the denominator, I need to put parentheses around it to force my calculator, if I was using it, to do the entire numerator, do the entire denominator, and then divide. So this is 8. Negative 30 minus 8 is negative 38. 21 minus 2 is 19. My answer will be negative 2. Go ahead and put that in without parentheses. You're not going to get negative 2. 27, 3 times 9 is 27, plus 15. 27 plus 15. It's 42. And 4 squared is 16. 16 plus negative 16 is 0. And 42 over 0 is undefined because I'm not allowed to divide by 0. Problem solving. Now there's a whole bunch of different ways to problem solve. This is one way, and then I'm going to tell you the way I normally do it. Understand the problem. Read the whole question. Read the question at the end that is being asked. Underline all the important information or make a list of the important information. Draw a picture or diagram. All that should be done first. Then plan a strategy, execute the plan, answer the question, and check the answer. Okay, some background information. Perimeter is the distance around the figure. It's in units. Area is the total number of square units that fill inside the figure. That's square units. Volume is the total number of cubic units that fill in a space. That's cubic units. And the circumference is the distance around a circle, meaning that it's pretty much the perimeter of a circle. Okay, this is how I problem solve. I read the entire problem. Then I read sentence by sentence and pick out the information that's important, and then I place that information together. A mason is building a rectangular foundation wall that is to be 75 feet by 40 feet. What is the total distance around the wall? So, A mason is building a rectangular foundation. So I'm going to draw a rectangle because I like my little visual. 75 feet by 40 feet. I need the distance around the whole thing. Well, the total distance around is perimeter. Perimeter is 2L plus 2W, which is on your formula sheet. So P is equal to 2 times my length, 75, plus 2 times my width, 40. So my perimeter is 150 plus 80, or my perimeter is 230 feet. If you take a problem and you don't take it piece by piece, it becomes overwhelming. So what you need to do is make sure that you take it piece by piece. That's why I read the whole thing, to take it sentence by sentence, and then put my information together. A tabletop is the shape of a circle whose radius is 4 feet. If the tabletop is to be covered with formica, how much formica is needed? So I got a circle. Its radius is 4 feet. And I'm trying to cover the inside, which is area. So area of a circle is pi r squared. Area is equal to 3.14 times 4 squared. The area is approximately. Now put the little squiggly lines in because as soon as I put 3.14 in, I estimated. And that means that somewhere along the line I've estimated. The area is 50.24 square feet. I know we're doing a circle, so it seems funny to put square feet, but all area is in square. A wallpaper hanger is to paper a bedroom wall that is 18 feet long and 12 feet high. How much wallpaper is needed to cover the wall? Okay, so I have 18 by 12, which is a rectangle. They want to cover it with wallpaper inside, that's area. Area is length times width, so the area is 12 times 18. 12 times 18 gives me 216 square feet. How to find the area of a composite figure. To find the area of a composite figure, you may have to break the figure into shapes that you can handle. For example, I don't know what the formula for this shape might be, but I know I have a rectangle and a triangle. My rectangle is 12 by 15, so 12 times 15 will give me that area. My triangle must be 7, because this is 22 the whole thing and this is 15, so 22 minus 15 is 7 by 12. So it's 7 times 12 divided by 2 is the area of my triangle. So 12 times 15 is 180 square feet, and 7 times 12 divided by 2 is 42. So together, I can add them together and take my 42 plus my 180 and get 222 square centimeters. Now you just have to break it so that you can figure out all the different measurements on the sides. Okay, so if I split this, it's 2 by 3. And if I split this, it's 2, and 3 is 2 times, this is 2, this is 3, that's 5, so this must be 5. And this is 2 and 2, so this must be 4, so it's 5 times 4. And then this is 2 by 3. So 2 times 3 is 6, plus 20, plus 6 gives me 38 square millimeters. Okay, that's not going to be right because 6 and 6 is not 8. Let's try that again. 6 and 6 is 12, so it's 32 square millimeters. So break it into shapes that you can handle and you can find the numbers on. Okay, the coordinate plane. The coordinate plane is also called the Cartesian plane. It is the x and the y axis. Here's the x-axis. Here's the y-axis. These are the positive on the x, these are the negative. Here's the positive y's, the negatives, and the center is 0, 0, which is called origin. It splits into 4 different quadrants. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And they are counterclockwise, so you have to know that. In quadrant 1, you will always find positive numbers. The x and the y will both be positive. In quadrant 2, you'll find negative positive numbers. The x will be negative, the y will be positive. In quadrant 3, you'll find negative numbers. Both the x and the y will be negative. In quadrant 4, the x will be positive, the y will be negative. And that's stated here as well. So I'm supposed to graph and state what quadrant they're in. Now remember, it's always x first and then y, just like the alphabet. So here's my x, here's my y. The x tells me to go left or right. Since it's negative, I go left 3, and the y tells me to go up or down, and since it's negative, I go down 4. Over 3 and down 1, 2, 3, 4. That's in quadrant 4. That's in quadrant 3, because a negative is in quadrant 3. Starting at the center, go left 4, go up 5. That's in quadrant 2. Go right 5, up 3. That's in quadrant 1. Go right 4, go down 3. That's in quadrant 4. Don't go left or right, but go up 4. What quadrant's that in? A lot of people say, well, it's in 1 and 2. No, there is no quadrant. If it lands on an axis, there is no quadrant that it's in. Go left 5. Don't go up or down. So this has a quadrant. That is none. Is it a solution? Well, to tell if it's a solution, you can plug it in. Now that we know that this is x and this is y, I can do 3 times 2 minus 0 equals 6. 6 minus 0 equals 6. 6 equals 6. Yes. Now remember, these are lines, so there can be more than one possible solution. 3 times 1 minus negative 2 is 6. 5 equals 6. No. 3 times a half minus negative 9 halves is 6. 3 halves plus 9 halves is 6. 12 halves is 6. 6 is 6. Yes. So don't just find one and then stop, because remember, line has more than one. Okay, graphing a point by plotting method. The plotting method means that we're going to make an XY chart. We're going to put numbers in for x or y. In this case, I'm going to put them in for x. I like to put negative and positive numbers in. Also, I like to pick numbers around origin. I can pick any number I want. I can pick 1,000,000 if I want, but I have to graph 1,000,000, and my graph is not big enough for 1,000,000. So if I put 0 in, 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. 1 squared is 1. 2 squared is 4. Now I plot them. 0, 0, negative 1, 1, negative 2, 4, 1, 1, 2, 4. Oh, it looks just like a little parabola. And it should, because remember I showed you parent graphs, and you'll know that a parent graph of a parabola has a squared in it. Okay, on the next one, I'm going to plug in for the y's and not the x's, because it'll be easier to solve. So I'm going to put 0, negative 1, 1, negative 2, and 2 in on the y side. So 0 squared is 0, negative 1 squared is 1, 1 squared is 1, negative 2 squared is 4, 2 squared is 4. 0, 0, 1, negative 1, 1, positive 1, 4, negative 2, 4, positive 2. This is called a sleeping parabola. But I can graph anything by using the x and y chart and plotting points. You can plug in for x or you can plug in for y. That's your choice. Now, when you're finding intercepts, you use the x, y put a 0 and a 0. This will give me the y-intercept, and this will give me the x-intercept. It always goes the same with the x and the y-intercepts. Okay, so what is my x and y? What are my x and y intercepts of what I have here? Well, I have an x-intercept here at -2, 0. I have an x-intercept here at 0, 0. And I have an x-intercept here at 1, 0. These are my x-intercepts. I have a y-intercept of 0, 0. Y-intercept. Now, what if I have an equation? 2x plus 3y equals 6. And I want the x and y intercepts. I plug in a 0, 0 in my table. This will give me the y-intercept because I'm left with y. Then I do what's called the cover-up method. I take the x and I cross it off. And I have 3y equals 6. Divide by 3, y is 2. Then I do it again, and this time y is 0, so I take out the y. 2x is 6, divide by 2, x is 3. And now I found the x-intercept. So if I'm doing it from an equation, I use the cover-up. If I'm doing it from a graph, I look at where it crosses at. Okay, percents of wholes and parts. Percents of wholes and parts are set up as a proportion. This formula is on your formula sheet. A fraction is the part over the whole, and then a percent is percent over 100. The part is usually marked by the word is, and the whole is normally marked by the word of. Okay, so if you see the word is and of, a lot of times that'll tell you what the part in the whole is. Okay, 40% off sale, off sale. The sales price is $144. What is the original price? Okay, I have a sales price is $144. The original price is the whole. Have no idea. I have a percent of 40, and some people would be tempted to put the 40 in there, but you can't, because 144 is what you paid for. 40% is what you got off. You have to figure the percent you paid for to go with the 144. Everything starts at 100%. If you've got 40% off, it means you paid for 60%. I have to use 60. I cannot use 40. Remember, paid, paid, off, off. Cross multiply. 14400 equals 60x. Divide by 60. 14400 divided by 60 gives me $240. So my original price was $240. Next one, 35% off sale. The original price is $162 per spark plug. What is the sales price? I don't know the part, but I know the whole. Now I have two choices here. I can put the 35% up there, but that will not give me my answer. That'll tell me how much I took off. Then I'll need to subtract that from the 162, and that's fine. You can do that. Or you can use the logic I used on the last question, and if I got 35% off, I paid 65%. So if I put 65 here, cross multiply, I'm going to get the answer right away and then not have to worry about subtracting later. So 1053 equals 100x. Divide by 100. X is 105 with a 3, but I can't have 3 parts of a penny, 3/10 of a penny. So always think, do I want off or paid for? Okay, and then readjust using the 100%. 6% of 12 is what? Is, I don't know. Of is 12, 60%. I don't need to change that because I'm not doing paid and not paid. So the answer is X is 7.2. 15% of what is 90? So 90 of I don't know, 15%. Cross multiply. 9,000 equals 15x. Divide by 15. 9,000 divided by 15 is 600. 600 equals x. What percent of 12 is 3? 3 over 12 equals x over 100. 300 equals 12x. Divide by 12. 300 divided by 12. 25. Now don't just write 25. It's a percent. So it has to be 25% equals x. Okay, simple interest. We're going to get into compound and continuous interest later, but simple interest formula is I equals PRT. It's on your formula sheet. I is your interest, P is your principal, the amount of money you're taking out or putting in. R is your rate. It must be in decimal form. And T is time, and it must be in years, which means if your time is in 6 months, you have to put half a year or 6 over 12, which is half a year. Okay, $2,800 loan is my principal. I have 14% interest at 1 month. What is my interest amount? So I equals PRT. So I is equal to 2,800 times my R. 14% must go as a decimal. To move a percent to a decimal, you move 2 spaces to the left, so it's 0.14 times my time. My time must be in years. It's in months. 1 month is 1/12 of a year. So 2,800 times 0.14 times 1/12. My interest amount is $32.67. So what is my total loan? My total loan is my $2,800 plus my $32.67, giving me $2832.67. Simple interest. If we all could get simple interest. I think the only people that get simple interest anymore are your parents. Principal amount is $1,400 at a 1.5% interest for 6 months. So I equals PRT. I is equal to 1,400. I know this looks like a decimal, but it's still a percent. I still have to move it over to 0.015. 6 months is 6/12 of a year, or 1/2. So 1,400 times 0.015 times 1/2. I is equal to $10.50. Now my calculator actually said 10.5, but since I'm talking about money, I need to change it into dollars and cents. So my total loan would be $1,400 plus $10.50. $1,410.50. Okay, now I've gone over a lot of stuff, but this is all the basic stuff that you should know before you go into this portion of algebra in the college algebra course, the pre-college algebra course. So please make sure that you understand these concepts, because these are the concepts we build on using variables, rational expressions, and so forth as we get into the algebra series. So take your time and understand these concepts. They're very important. It's your turn to practice.